for Fujitsu Australia. I've been working with Postgres for the past 10 years on and off. Did some development, mostly do DBA sort of activity. This is my second PG Con, so relatively new compared to many people. So what we are going to look at today is how we can achieve multi-tenancy in PostgreSQL, what's available today, what can be done, and what more needs to be done for different use cases that may be out there. Part tutorial, part just tossing off ideas, because we had a big unconference day yesterday. It's still in unconference mood, so please feel free to jump in anytime. Okay. So looking at why do we need multi-tenancy, and I'm looking at it from Fujitsu's point of view, obviously, and Fujitsu is a big hardware vendor. We build really big machines, and so hardware consolidation is something that really interests us and our customers. You may think that these days not many people are buying bigger and bigger hardware. They're more into virtualization, into cloud, and things like that. That is true to some extent, but there are still bigger machines being built, appliances being built. We do have a Postgres appliance, and people are still using it. What do they like about these appliances? Obviously, it's the plug and play. It's the simplicity. It's the productivity gains that come with that. So hardware consolidation is a big key. So when you buy a bigger machine, you want to put more and more instances into it, or whatever you are running on it, you want to put more and more, and you want all of them to play nicely with each other. You don't want them one killing each other. They all sit there sharing the resources and things like that. So that is one of the big attractions for us when we look at multi-tenancy. And resource sharing comes out of that. All of those instances has to share the resources. And then cloud solutions. Cloud solutions is a very loose term. We'll look at it in a couple of slides after this. What that means is, there are solutions like RDS out there. RDS being very public, but there are a number of other database as a service solutions in many private clouds, which are not as sophisticated as RDS, but they still need something at the database level to make it really efficient. So that's where the need for multi-tenancy comes in. So when someone is looking for multi-tenancy, what do they really look for? Obviously, security is the first thing. Security not in a traditional sense. They want data isolation. That's one of the key points. Not just data isolation, the data resource isolation as well. So the users, they have to be separate. One user shouldn't know there is someone else by this name in the same instance. So everything has to be clearly isolated. So my user, my data, everything is separate. And then comes optimal resource utilization. Everyone wants to build a system that is being used optimally, but they don't want to wait. So it has to be perfectly tuned or perfectly delivering the service. So that's what the optimal resource utilization means. You buy a big system or small system, doesn't matter. You want the services running inside it to really use all of the resources much efficiently without having to compete with each other. This is an ideal world, obviously. Then application transparency is no big deal. It already done. You can already do this. Sorry.
When we're talking about resource utilization and multi-tenancy, you also want to limit resource utilization by one tenant.
Yeah, exactly. Yeah, I do have that in later. Yeah. So there is resource allocation as well as resource restriction. Yeah, both viewpoints are there. And then there is application transparency. Yeah, it's no big deal. You can already do that. Applications with PostgreSQL, it's really good at it. You're connecting to the DB, and port is there, but so the application doesn't know whether it is connecting to a big cluster with thousands of databases in it, or it's just connecting to a single instance with single database. So that already happens, but nevertheless, that's one of the things that's needed as well. So this is looking at a use case. It's a bit blurred between requirements and use case. But nevertheless, what are the use cases? Why do people, apart from the points we looked at in the first slide, what other things do they look for, or why do they want to go into this area? Unified platforms across cloud and on-premise. If you look at the Oracle's database appliances now, they actually have OpenStack inside. It's exactly the same platform as they have in the cloud. If you go to Oracle Cloud, it is built on OpenStack. The services, DBaaS services available in their cloud platform is exactly as the one you get in your Exadata. No, small differences are there, but mostly it is the same platform. Why do they do that? The customer, they want to have a uniform experience. They don't want to have a DBA who is very specialized in the cloud provisioning, managing cloud instances, but then need to have a completely different skill set to manage on-premise instances. So that's where the appliances world is moving as well. And the appliances we do have with PostgreSQL is also looking at that space. So everything has to be uniform. You can move across cloud and on-premise without having to change any of your practices, move seamlessly back and forth. Then there is the other end, which is generic infrastructure for DBs. Again, you don't want to have if you don't have specialized hardware, you don't have specialized appliances or platform, you still want to do many of the things you would do in the cloud or with multi-tenancy in smaller systems as well. And then easier integration with other pieces in the IT stack. It really doesn't fit with multi-tenancy, but nevertheless, you want your systems to play with your backup and storage infrastructure, for example, your authentication infrastructure, for example. So they all have to work together because most of those things are already in a multi-tenanted way. You can restrict it based on users or instances and things like that. So what do we mean by multi-tenant? Depending upon who you talk to, you get different interpretations. They all can mean really different things. The basic one is obviously you have a single piece of hardware, you want to run multiple instances in it. This is what we do already in PostgreSQL, obviously. That's the purest form of it. But then if you look at from within the database point of view, then you won't have one instance, but you then want to have several self-contained databases. You want to have the database with the users within the database. They don't see, the catalogs are within the database. They are not shared among each other. So all those things, it's completely self-contained. And user logging into a database has no idea what other databases exist in the system. This requirement or this definition is what mostly people consider as multi-tenant. What we have in the first one, that's single piece of hardware or multiple instances, is actually a workaround to achieve the same thing. But when you want to have a truly multi-tenant one, this is what you go for. Then there is the extremely niche requirement, which is one instance, multiple customers, multiple instances. It's something like database.com, for example. It's one gigantic instance with one database, as far as you can view, with several tables spread across multiple customers, multiple users, all technically in the same database, using RollLevel Security, RollLevel Visibility, and all those things. Now, this is not going to happen for 99% of the users. This requirement is not going to exist. But with, as I said, many people looking at building private RDS solutions, this requirement may become more and more common as well. Okay, so let's look at the single piece of hardware and multiple instances. This is what you can already do, but even if it can already be done, there is really no way to control how much resources they consume, how they interact with each other. for example. You know,
Have you considered CGroups?
I do have that in 2 slides later. Okay. Yeah. So what I'm talking here is from a database point of view, from within PostgreSQL, what you can do. You want to be able to say, especially in a cloud environment, when you want to set SLAs, you want to say, if I allocate 2 CPUs or if I allocate this much memory to this instance, it is always going to have access to that much amount of memory. There is not going to be hogging by another instance. Okay. And then you also want to restrict, you know. So you have the minimum level, and then you also have the maximum level, you know. SLA is fine. In the SLA you define minimum, this is the set of resources you are going to have, but maximum is also there. So that needs to be set as well. And then resource sharing. They don't go along well with each other, but you can have a hybrid situation where if there are free resources in the system, why not allocate it to others? No one is using it, and if someone else wants to have that, sure, allocate it to them. So there are 3 things when we are talking about the resources. And what are the resources? Fairly common: CPU, memory, and disk. You want to limit and restrict the usage of those. And CPU and memory, fairly self-explanatory. And disk is, the storage limit per tenant as well. Okay. So this is just a very simplistic view of how the multi-tenancy would look like. And this is on a virtualized environment, obviously. So you have 3 VMs on a hardware, each running some sort of middleware on top of it. And if you look at the graphs, they all align perfectly. They have different peak periods, but and not at the same time, obviously. So you have large amount of resources, be it CPU or memory or whatever, sitting idle at different points in time. So if you are going to pull them together in a bigger environment, then why not put it in a multi-tenanted environment? Now, why you want to, apart from the obvious choices of resource allocation or usage, why do you want to combine it in all in one VM? There are several reasons. VM swapping, VM porting, VM failover, all these things which are available in many of the virtual platforms that's available these days. You can make use of that. It becomes much more simpler having to port one single VM compared to having to port 3, 5, 7 VMs. Sure, depending upon the virtual platform you choose, things can be easy. But from a database point of view, the simpler it can be, the better it is. As far as
Does MW stand for?
Middleware. Middleware. Yeah. Yeah. Okay. Yeah. So this is the multi-tenancy use case. So you have the resources; they need to be available all the time. So what we do have in PostgreSQL already is, we do have separate instances that we can already do. Strongest data isolation. Once you connect to a particular instance, you have no visibility of what is available in the other instance. Fairly straightforward. You can already do that. Then we also have separate databases. Again, from a data point of view, once you connect to a database, you don't see other databases pretty much. Well, you can see, but you cannot cross-link. And it's simplified data management. And then you can also, if there are multiple users, but you still want to connect them to a single database, you can split them into separate schemas. So that is also already available. But it does have, obviously, a large maintenance overhead, especially thinking when we don't have automatic user creation for schemas. So it does come with its own overhead, but nevertheless, it is there. You can easily write scripts. Scripts are already available to do those things. But all of the above share the hardware resources. they still compete with each other. So the solutions we have. So what can you do? CGroups. So I don't know if how many people have used this. So CGroups is a Linux construct. So what you can do is you can pool resources into multiple groups. Be it there is a list of the things which you can pool based on CPU, based on memory, the I/O throughput. All this can be grouped together, and then you can allocate them to a process. It's as simple as that. And you don't, and it is not like you can only allocate it to a pre-running process. No, you can actually define a process that will start in the future and then say that process, when it starts, should go into this group. So that's how you set the limits. It's fairly straightforward. If you look at the configuration file, it's very similar to pghpa.conf. It's that style. Anyway, so this can already be done, and pretty sure many people use this when you are running multiple instances in a big system. But it does have its limitations as well. As I said, it's mainly process-based. But if you look at it from a database point of view, wouldn't it be better if you could limit it from a based on users, database users? You want to say this particular database user, when he connects, it starts this particular process, so that client connections belong to this user. This is the group he should go into. So not just any Postgres process, it's just a particular process that is connecting to a particular database with a particular user.
I'm not so sure I want to do that, because inside of one instance of Postgres, things like lock sets, etc., are shared. And if you restrict one process, I mean, we had this way back when all this didn't exist with nice levels. It doesn't really help the overall throughput of the other processes if you hamper one back end doing its work as fast as possible.
No, but you would do this on a, I mean, I would think you would do this on an instance basis, not on a single process.
Yeah, for CPU sets, probably on an instance on the postmaster level. Yeah. There it makes sense. Yeah. On the user level, no.
On the user level, it does.
If you identify the user with postmaster process, then yes.
Yeah, that's what I mean. So the user,
that's what he's talking about.
Yeah, so the user connects to the database, obviously. So then you have that connection. Then you have that translates into a process, the postmaster process. It spawns.
They're all children of that postmaster.
Yeah, that's.
Inside the same control group.
Yeah.
I can definitely see it being a problem, though, like priority inversion. Well, where I've seen people deal with that approach is using U-limit. It's not so good for CPU utilization. You can do it for memory and other stuff. You can U-limit the individual backends, and that actually seems to work.
I think a problem is the priority inversion, really, because there isn't that much in the backend where you have one backend waiting for another. That definitely happens, but those sections are very small.
Well, I think the ideal way to deal with this would be for us to have the control over it, so we can make sure that those little bits of code never end up being able to be used for priority inversion, or end up having that happen.
Yeah.
The outside system can't tell that, right? They don't know when we're in certain bits of code and when we're not. So
it's definitely possible in theory to write the backend so that there is never a situation where you have to wait a while.
Yeah, that's definitely the viewpoint as well. Because as much as you can do it easily and it works with outside of the database, you still want to have something that translates within the users and the database of, the PostgreSQL instance.
Have you tried that?
Pardon?
Have you tried that?
I would say yes, but not in a serious way. I would say we have been playing around with it. Yeah, we don't have anything ready or any solution as yet. Yeah. Okay.
I've played with CPU sets recently.
Yeah.
And I have to say, really setting up separate VMs and giving them priorities works a lot better, because then you have one VM that has a low priority, but as long as nobody else needs the CPU, they can use the whole server.
Sure.
Yeah. You can set standing up with control groups.
Yeah.
I have not
They're cool.
tried that.
They
Yeah.
are neat. They control groups
Okay.
are pretty cool.
Yeah.
The way of doing it all underneath of one kernel, which means you don't have the multi-kernel overhead. You get with
Yeah.
full VMs, which is really nice.
Yep. So yeah, so the C groups are basically at kernel levels, and what I was talking about is, yeah, wouldn't it be better if we can control it or have some sort of link with the database objects itself so that we can control it better? So when we compare that multi-tenant use case to other databases, I think we looked at this. One tenant cannot find out the other. Not quite in PostgreSQL. User can access the database data, but in multi-tenancy, we want to keep them completely separate. So one option is to have, I mean, this has been beaten to death in several discussions in the hackers group, but nevertheless, I'll bring it up again. Yeah, so ideally, we want to have database specific users, roles, and users that are limited to just within the database. So one way you could do that is to create role to have the scope of that role. So it could be cluster void or it could be database void. And so it's self-explanatory. So cluster void users can create to any database in the cluster. Database specific users can only connect to that database. The roles associated with database cannot see the data not belonging to that instance, goes without saying. But as always, again, the question always has been, how do we treat the shared catalogs? Who gets to see what from that shared catalogs? And how do we split across the databases so that the data that is not specific to that database is not visible? So maybe RollLevel Security is the answer. We do have RollLevel Security in 9.5 now, but it is not available on system tables yet. But maybe the natural evolution is to extend that into this particular use case we want to.
I mean, from my 2 cents, I think that's going to work a lot better when you're talking about things like, maybe schemas and whatnot. With roles, so much of the system doesn't go through the, doesn't actually query the system catalog to see what you can actually get at, right? And so, you can still, if you try to grant, X, Y, select on whatever to some user, you can detect that that user still exists.
Yeah.
Is that an issue or not is perhaps a different question. Maybe it isn't an issue. But, where I find that kind of falls down is in particular with roles. When you want to create a role that has the same username, maybe Steven, as somebody else has, right? That just completely falls apart, right? We really need to have, some notion of the locality like you're talking about of, per database, I think, for
Yeah.
at least roles. Maybe other objects, maybe, different. Schemas is probably a good example of a case where you're not going to have, presumably one person or small group is creating the schemas in your database. People aren't just arbitrarily creating their own schemas, and so for that case, maybe you can get away with it because you don't have to worry about it quite as much as username issues. Yeah.
Is there any way to limit the size of a particular database?
Yeah. With the C group, you can.
With C, yeah. Again, outside a database.
You can limit the size of that, what's
Yeah.
allowed in that directory, essentially.
Yeah.
How big a certain directory is allowed to get.
But then things go when it caps out.
Not if you don't put wall in there.
Failure, isn't it?
If you don't put wall in there, then it actually, Postgres will properly handle it, except if you run out of wall space. If you run out of space for wall, database is gone, which is a big problem. But if you don't limit PGX log and you do limit the actual database directory, the OID of the database directory underneath, then that actually should work just fine. It won't, it'll just give you an error when you hit that limit. And whatever command you were running will get rolled back and whatever.
Yeah.
Free some space and off you go. The system should operate properly.
I actually do have a slide, 2 slides later on that one as well. Yeah.
All right.
No, that's okay. I don't have a solution. I just do have a slide.
Reviewing your slides.
Yeah.
I promised I didn't see them.
Yeah. Yeah, so row-level security is something we are looking into also, how that can be extended across the system catalogs to really limit that information. So one of the options we were looking at is to select using object IDs less than the first normal object or based on the user ID itself. So it would look something like this, conceptually, please. So it's not a solution yet. So the idea is to just create a policy during the initDB itself.
Oh, I see.
Yeah. It's not, as I said, it's not a completely tested theory yet. But this is one thing or one possibility that we could do. So because it is done at the initDB time, then users who don't want to have those limitations doesn't have that overhead. They still get to see everything else. So this is based on the oldest normal object ID and when the user was created and all those things. So this is a possibility. This can actually probably be done already.
I have a feeling that we're going to need to be able to, I'm not sure we're going to be able to have one set of policies that are set at initDB time for the catalog.
Yeah, it doesn't.
I don't know.
Yeah, it doesn't scale. I agree.
Yeah. It's an
But-
interesting idea, though.
Yeah,
But I still think you have to deal with that other question about, do we care about, the name resolution at the end of the day, what it ends up being.
yeah.
You can still reference names that you can't see through the
See
catalog.
through the catalog. Yeah, that you may still be able to do. Yeah,
So it's-
you can
maybe
still.
it's not an issue. I mean, in some environments it probably doesn't matter, but some environments it will matter.
Yeah, it's more like the user trying to send a probe, and it depends upon what you return back. You don't.
Again, though, where you have likelihood of overlap, you have a problem, which is common in users.
Yeah.
Usernames.
Yeah.
That's the
PG
big.
class is actually not a shared catalog, so that's a big.
Well, that's true. Yeah, PG.
Yeah,
That's
that's-
something you could do.
So
Yeah,
what shared
yeah.
catalogs do we have? We have roles.
Database,
Dependencies.
namespace.
No,
No, namespace is not shared. Yeah.
Well, we have a shared dependency as well as a local dependency.
Yeah.
What else we got? There's a shared security labels one and a local security label one. I think that's, those are definitely the ones that come to mind. So, the database one might be one that, I mean, it depends on,
That's-
in this
yeah.
environment, you probably are not letting arbitrary people create databases. And then, so in that case, having a policy that means that you can only see your database and PG database is probably fine.
Maybe we don't even need to see that.
Well, we could just revoke rights from it completely, but I don't know. We could, I understand, we could revoke rights on it completely if we wanted to, but it seems, I don't know, I feel like there's stuff in there that people might want to be able to see. Maybe I'm wrong, I have to go look.
So does this also mean that people can only see objects that they own?
That's right. Yeah, yeah.
And then if you put the same thing on PG, REL namespace, or PG namespace, then you can only see the schemas that you own.
Yep.
Right? I think you'll have to, you probably have to get through and actually change it to be more grant-based, right? You only see the schemas that you have access to.
Yep.
Usage at least, usage
Yeah, the usage would be the next level. Yeah, the grant would be the next level. Yeah, yeah,
And You gotta flesh this out a bit more than just ownership-based.
yeah.
I definitely understand the idea, and it's something I've been thinking about.
Mm.
Absolutely.
But this policy won't be for the super users, right? It's just people.
No, not for the cluster
Our
base.
OS
Yeah,
apply to super user
it
benefits
doesn't
anyway.
not. Yeah, yeah. But where the super user becomes tricky is when you have when you want to create a super user for the database itself, because now you have a super user for the cluster and then another super user for the database. What sort of rights do we give that super user?
Not the ability to create C functions.
Yeah. So that part comes in as well. It's easy to say we can limit that database super user to exactly the same set of privileges as the cluster super user has, but contained within the database. Meaning they can create other users, they can create other super users. It still might work, but yeah, once we have this construct, then I think that is easily solvable. That would be the least. It's just setting the policy. That's it. Yeah.
The concept is called the database owner, but that is the person who can do anything in the database, right? What more privileges do you need?
I think you run into things like, the first one I can think of is create extension. And that's where things get tricky, right? Because I want to be able to create PostGIS in my database. So, but you need to figure out a way to whitelist that and then only allow the create extension script to run as super user, not let the user calling a create extension to run as super user.
It's doable.
Huh?
That's doable.
Is it? Are you
Yeah.
sure?
Someone might have done it.
Yeah, someone might have done it. Where's the patch?
Yeah. We can talk about that.
Provide the security defined function or something.
It's
Yeah.
all the other pieces though where is super user,
There are a bunch of other ones. I'm trying to fix that.
yeah. So far there's like 2 new ones in 9.5.
I'm still trying to fix that.
Yeah.
Didn't happen for 9.5, but hopefully 9.6.
Yeah. So what other things are there?
Other
Other things you need super user rights, time create extension, but well,
Oh, probably anything, well, yeah, I guess there's some question in my mind about database ownership, allowing you to do things like drop any object. I'm not sure.
Yeah. Like you usually need to be able to alter all the objects in the database.
Yeah.
Yeah, and I don't think our system currently allows you to just do that
No.
as database owner.
No.
It's not,
Yeah,
database
that's
owner
what
gives
we
you
had to
certain things,
fix.
but not that. So it's not truly like it's not like super user which bypasses things. So I think that may be something, it's an open question for debate perhaps about whether we should relax that, those permission checks for database owners or not. You can get that object dropped, right? I think you have to drop cascade the schema or something in order to be able to actually get rid of it if you wanted to drop a particular object or something like that. So it's pretty grotty. So I'm certainly open to suggestions on it.
The other thing is also like what happens when you delete a database specific user and what happens to the ACLs for that user or for the database spanning objects.
Deleted database can go away. Are you talking about like
The,
ranking roles to roles?
yeah, for the roles, the
That's-
database specific role, yeah.
Yeah. The other thing is you have to have, everything has to be database specific, and you want to be able to let whoever that database owner is arbitrarily grant roles that
yeah.
are in that database to other roles, right? Which is something that you can't do today at all.
Yep.
Right? Unless there's the create role option, but then in today's world, right, that would allow you to monkey with roles in other databases, right? Because we only have one set of roles right now. You really have to have that locality bit first. And then you can start to consider how we could set up permissions to allow that to work.
Does Oracle restrict users from, the system? They do that?
Yeah, you can do that in Oracle, yeah. And I think the requirement actually comes from Oracle people, yeah.
I might be missing something simple, but why multi-tenant instead of just running separate master processes? It's like I said, didn't catch the problem you're trying to solve.
Oh, okay. So when you have different postmaster groups, basically, yeah, they don't know about each other. And then how do you make sure the resources are being shared really well?
Because you could tighten one down, but it can't really expand itself.
It can actually. It will grow, because there is no restriction on it. So it will try and get as much process and memory as it can. So the idea is that you don't run multiple processes. What you do is you run a single process, but then the instance itself is multi-tenant inside. But then we are able to control how much each user or a database is able to consume from within the database itself. That's the grand design. That actually is what we are trying to do.
Just to give you an example of the problem, if you set shared buffers to 1 gigabyte and you have 1 million databases,
Yeah.
if you try to run that, you need 1 million gigabytes of RAM for that to work. But if they're all in the same instance, then they will share buffers.
Yeah.
So if you have a lot of databases that get one query per day, it's really wasteful to run separate instances. Or if you just let them swap out the disk, that often that actually works.
And it works the other way around as well, to be honest. Like if you have multiple instances and when they want to do something, there is available memory or even CPU core sitting there idly, it can always use it. But once you restrict them, once it reaches that limit, it cannot go any further. So that part is there. Yeah, so it's not a perfect scenario. But for most of the use cases we are looking for, that's what we want. Yeah.
Another practical problem, you will run out of TCP ports if you try to run more than 64K.
Have you looked at the trade-off between running, let's say, 100 instances, right, versus an instance with 100 databases?
You mean from a performance point of view or from a usability?
CPU, generally from resource consumption perspective, how does it, is there a limit, is there an additional overhead being introduced by it?
There is definitely an overhead in running multiple instances. Yeah, so that's easy.
More than
Yeah,
a handful is not gonna work.
yeah,
Yeah.
yeah. It's very straightforward. You save a lot by reducing the number of instances you run straight away. Yeah.
When you talk about sharing shared buffers, are there any mechanisms that allow you to control fairness?
Don't think so.
Not today.
No.
Isn't that like one of the biggest problems?
One of the biggest problems we have is that we don't have any consideration for what pages are more useful than others right now.
Yeah.
Forget priority of people, like, we don't even have it, we don't even realize that, gee, that B-tree root page should probably stay, because it's been accessed, 18,000 times in the past 20 milliseconds, right? It's like,
That's-
It's just not very clear.
it's just not, well, it's horrible, because everything ends up at 5 if you actually have a high amount of, pages being accessed across, in a random way across the entire system, and then we arbitrarily kick stuff out. That becomes a really cruddy way of doing it. And oh, by the way, we only do that after we've gone through the whole freaking thing.
Yeah, that actually is one of the discussions one of my colleagues started in the hackers list last year. But then PG pre-warm came through, and we got lazy, and then and then it's a workaround. So in some way,
As long as everything's in.
Yeah. Yeah. So, but yeah, as Steven says, it's not an easy thing to do, though. Yeah. It's easy to implement, mind you. It's difficult to define your definition of what is important and what is not. That's where the difficult part comes in.
We should start. I mean, from my 2 cents, we should just start doing something there. Or
Yeah.
At least pick off the obvious ones, right?
Yeah.
Makes a lot more sense to keep the root of a B-tree page than some leaf inside of it.
Yeah.
Period. And let's just start there.
Another problem is that if you try to set max connections too high, that will also hurt your performance really badly.
Yeah.
That's really
So
annoying.
I said earlier, if you try to put a million databases on million instances on the same server, that's going to suck. But it's also going to suck if you actually try to set max connections higher than 1,000.
Even 1,000.
Yeah, it depends on the workload.
Well, another huge problem we have with 1,000 instances is that you actually use 1,000 instances and you're burning memory like mad because of all the shared catalog, all of syscache ends up getting populated in every backend, and it's all the exact same data across all of the instances, and then someone dares to actually, make a modification that requires signaling everybody to go update cache, and you're like, oh.
When we create database, is it two different kinds of databases, tenant and multi-tenant?
No.
Or only one?
You can have multiple databases, but
But one type of database, it's the same type of database.
yes, yeah. That
We try to restrict that thing around,
not really. The database characters doesn't change. They will be exactly the same as the others. What will change is how they consume the resources. Yeah, but
In fact, it's opposite, that you can say, oh, this is a dedicated database for this user, and it doesn't see anything, and this is database, like, it's not dedicated, but it's
No, it would be the other way around. Like you create a database and then you can assign users to it, but those users can only see that database. But if you want, yes, you can restrict it to a single user as well. That can also be done with the policy settings. Yeah, you can do that as well. Yeah. The last slide I have is obviously what you were asking. Yeah, how do we limit the data size? And as you mentioned, we don't want to limit the instance size. The instance has to grow. Otherwise, it will completely shut down once it cannot write any more Xlog. So what we want to limit is the table space, actually, the data which you put into the table space. And once it reaches the limit, you get a warning or something. Now, again, this can be done with CGroups, and you can also implement it internally in PostgreSQL as well. But the difficulty comes in is, OK, so you have a table space of 20 gig, whatever it is. You fill 20 gig. What happens next? How do you stretch? How do you grow? Do you spill over, create another table space, or do what we do now, is create another bigger table space and move everything into it, locking your database during the process? You definitely don't want to do that. So
Handy command for it now, if you don't mind that. Just move alter table. Move
yeah. And then, of course, who monitors it? That's the other thing. Do you create another daemon to just wake up every 5 minutes, just like auto vacuum does, and monitor which table spaces are about to run out of space or about to be fill in? So all those questions come in, and just like anything else, the implementation is fairly straightforward. It is just defining these policies and rules about what happens when it fills up, what happens when how we monitor. These are the difficult part. But if you want to restrict how much storage your database is consumed, yeah, you can do that already externally. Put a C group around the table space. There you go. Yeah. Okay. That's all I have, actually. 4 more minutes left. Yeah. Any other questions?
One problem that we found with managing multiple tenants, lots of tenants, was the migration of tenants. Right? So if you have, that's why I was asking before about measurements, what happens if you have a lot of instances? Because obviously if you have a lot of instances, moving the tables associated with a tenant to another machine becomes a lot easier when the tenant grows fast. Whereas if the tenant is a database, right, moving the tenant to a machine where there's more headroom is a big problem.
True. Right? Yeah. But how would you just move the table, though? How would you just migrate the table?
Well,
yeah.
If the tenant is an instance, it's easy, right?
Yeah.
But if the tenant is a database, it doesn't work.
One big problem there.
It's no, I mean, maybe not today, but logical replication
Of course, yeah.
will.
People are hoping he's going to help with that problem.
Yeah. Yeah.
Hopefully, we'll see.
Yeah, that's where it becomes very, very useful. Yeah. But with the logical, so the reason I paused is with the logical replication as well. What happens to the initial snapshot? Yeah.
It'd be nice if we didn't have, if we had per database C-log stuff, so that you could like get all the data in the database, and it could be self-contained, and you could actually move it.
Well, yeah, I've actually, my insanity, I'd love to be able to take a table with indexes and move it.
Yeah.
Right? If we can figure out a way to do something like that, then the table space problem, or database problem kind of goes away. But to do that, we need to figure out a way to like freeze everything, or do something along those lines, some way of we'll rewrite the table with only frozen pages, and something like that, to allow us to then be able to migrate it without having to deal with all the visibility questions that come along with it, right? I think
It
that
would be nice to have per database XID space anyway, just so that
Yes,
you could
actually,
have
that-
more,
Yeah,
you can burn through the same.
that would be
resource.
fantastic. I definitely agree with that idea.
Another problem with the multi-tenant that we saw, that if the tenants have different ideas about kind of when it's okay to restart the service, then you have to more or less, if you are doing upgrades, then you're restarting everybody. So you
Fair point. Yeah,
You
yeah.
kind of can't let individual tenants restart the service.
And I mean, not that, so if you are doing yourself the maintenance, for example.
Oh, you're saying if you get a request in.
Yeah, you're going to request
Okay,
that,
right.
or you're doing security updates or whatever.
Yeah.
I'm glad to hear that
It
you're
says
not-
I can be kind of, we can restart in the morning, another says, oh,
Yeah.
in the morning we have the highest kind of load, we have to restart in the evening or whatever. So
Yeah.
it's kind of,
That is a valid point, though, but
it's
that's,
probably not the major problem, but
I
this
did-
instance,
well.
putting them in different instances, for example, helps. Yeah, so
Oh,
it's
that
kind
does deal with it, yeah. I was
Yeah.
just trying to say, I mean, if you're gonna go with this approach, it's not really a manageable problem, is what I'm trying to get at. Until we come up with like, something like case splice in Postgres, right?
So solution in this case is more kind of.
No,
in
like,
some ways.
when it comes to appliances, you actually exactly do the opposite and try and avoid that, because you don't, the users exactly don't want to do that. They want rolling upgrades, and they don't want just, what's the word? Everything is the same. They don't want multiple versions and things like that. You don't restart a particular tenant. It's just one gigantic appliance just sitting there, and upgrades is just rolling. You don't want to shut down and start, things like that.
I think
Yeah.
one idea I find very interesting is how, why is my brain failing me all of a sudden? Not PG Pool, the other one, PG Bouncer. Right, PG Bouncer has some mechanism for basically replacing the binary, right? While continuing to maintain all of the connections and everything and
Yeah.
keep going, right? We have something like that where you could essentially upgrade the postmaster, and then all new processes that are forked off of it get, the upgraded minor version. Something like that would be really cool.
Which is what
Then
PG
you
Pool.
can do like a rolling upgrade through,
Yeah.
From all, your PG Bouncer or whatever is connecting to your database can rolling upgrade to the new version that way.
Sounds a bit what they do with Cluster HQ, Docker, where essentially if you use the Docker images and then afterwards they copy the database and keep the deltas at the last minute.
So,
Okay.
yeah.
Interesting.
Yeah, how we do it today is, we already have an appliance and everything is, duplicated. And the way we do rolling upgrades is, we do have this internally developed proprietary thing which holds onto these connections, just like you say, PG Bouncer. So the users or applications don't get bumped off. So we then switch to the standby or and then do the
Yeah, right
do
now
the
you
upgrade
lose
of.
all of any prepared statements, anything right now, right? With the approach I'm talking about, you potentially keep all of that.
Yeah.
Right? You wouldn't have to, lose all of that. And that could be a big problem with some of the big applications that really use a lot of prepared statements.
Yeah. And by the way, PG Pool is also, Ishii-san had a talk on Tuesday, and that's what they are trying to do as well.
Okay.
With the,
Alright,
yeah,
cool.
yeah,
But it'd be better if Postgres did it.
true, yeah.
Instead of having the poolers do it. 'Cause
Yeah.
You have a lot of prepared statements and you switch over to standby. Even if you know what prepared statements you have, you still have to pre-prepare them. So I don't see how that really helps. I mean, honestly speaking, you have to design your application so that you can lose the connection at any time.
Oh man, I so wish I could get them to change. I really do. Believe me, but they do not. Yeah.
I mean, this is,
Agreed, but
this is.
they're like,
the
well, just
kind
restart
of
the instance then, like the application instance, like, oh, that's ugly.
Actually, I blame it to Postgres because it's so stable that developers are.
It's all our fault.
Developers more or less know that database is always there, kind of like this.
It would actually be nice to have like a fault injection mode where you could test your application with a slightly faulty Postgres instance, randomly throw errors here and there and all that.
In the test environments,
Yeah,
yes.
yeah,
Or maybe not random.
In some strange patterns.
Okay, I think we have to wrap up because the next one has to start. Thanks, everyone. Thank you. Thanks.